I do want to say, as we're talking about graphs, as I was grading the worksheets yesterday, I told you I was going to be pretty picky on graphs, and I want you to make sure you're not making pointy graphs, right? Like if you draw your graphs and it looks like this comes to a point instead of a nice smooth curve, I'll probably take half a point off or something. Because I want you to realize you have to make smooth curves, all right? So just be aware of that. We'll see how it goes as I finish the worksheets and give them back to you. But to have an inverse, we talked about this in Algebra 2. We talked about it last semester. In order to have an inverse, a function has to pass the horizontal line test. Because remember, to be a function, it has to pass the vertical line test. So if you want to switch the domain and range, which is what inverses do, then it has to pass the horizontal line test. I put sine here, but do any of our trig functions pass the horizontal line test? No, because they all repeat themselves over and over again. Yes? So I put, but it fails.
Well, I just wrote that out for nothing, man. I thought it was a 40.
Well, if you listened, I told you just a second ago not to write this down, but to just
I was already
listen.
writing it down before you said that.
That's not true. I told you not to write it down before I turned the slide.
I wrote it down before you said that.
So here's what we can do, right? Instead of just saying, oh, I guess none of the trig functions have inverses. We're done. Let's skip this section, right?
Right, wrong. Let's do it.
We can say, well, what if we just look at part of the graph? What if we just say, what would the inverse of sine be for just one section of the graph? And we could look at lots of sections of this graph that would pass the horizontal line test, but you have to meet some requirements, all right? And you don't have to write these down either, but just math-wise, how do they pick this? If we look at from just negative pi halves to pi halves, negative pi halves would be like right here to right here, right? Do you agree that would just be this section of the graph right here? Why do they pick that section? One, does that section pass the horizontal line test? Yes, there's lots of sections, so why do they pick this? Here's some other reasons that they pick this. It has to be, I think they call it monotonic, which means that it's strictly increasing or strictly decreasing. And do you agree that from negative pi halves to pi halves, this graph is increasing the whole time? Yes, that's good. It also covers the entire range from negative 1 to 1, from negative pi halves to pi halves. And the big one, it passes the horizontal line test. So here's what I want you to get about these inverse trig functions, that you don't have to write this down. We'll write stuff down in a minute. That all of the trig functions inverses are going to be restricted over some interval, because you have to make it past the horizontal line test in order to be a function. So the big thing that you have to get out of this is not the graphs, all right? We're going to look at the graphs, but you have to get where am I restricted of giving my answers to, and that's the part that we tend to forget. So you can write this down now.
Sure.
Yep. Start with this. On the restricted domain from negative pi halves to pi halves, we can say that sine has an inverse. And if you think back, or if you look back to when we did inverse functions in chapter 2-ish, I think, sometimes they would give you a function's inverse, and they would give, like, comma when x is greater than 0. Because they were restricting the domain so that you could have an inverse. So the notation for inverse, sine, this is the one we're used to already because we have that lovely button on our calculator. Negative 1 power here does not mean negative 1 power, it means inverse sine. Or the other way that you can write inverse sine is you can say arc sine. I will use both interchangeably. The book will use both interchangeably. You need to know that those mean the exact same thing. So arc sine or inverse sine with the negative 1 power both mean inverse. The big thing to remember is inverse functions switch the domain and range, yes? The x's and the y's switch. So think about, and then we're going to write this out in a second. Normally, what do I plug in here? Angles, and I get out the values, yes? My x-axis is angle, my y-axis are like 0, negative 1 to 1. When we do the inverse, we're switching. Now my y-axis is angles, and my x-axis is numbers, because we've switched the domain and range. So I kind of wrote this here, that here we plug in angles and we get out values. For inverse sine, which these mean the same thing, so I just wrote them both ways, but for both of these, the x value now, we're going to plug in values and get out angles. So the big thing is just the thinking through of your answers are going to be angles now in terms of solving these problems. Instead of grading your homework quizzes last night, I worked on Pi Day songs. That was really productive, right?
I was about to say, I guess I improved some items.
4 weeks. 4 weeks from today is Pi Day. Well, not really. Pi Day Eve, because Pi Day is Saturday. But I told Miss Vi, I'm like, we need to get this together because I need to get the music together. So Miss Dowd can put the music together. She's like, it's forever away. I'm like, it's 4 weeks from today. We have yet to do anything with it. So I just buy a shirt. Better.
Wow, you're gonna put us.
Yeah, I'm gonna make the food 4 weeks in advance.
Just think about refrigerators.
I don't make food anyway. You bring food, right?
Pretty sure there's that food promise. I think it's your syllabus.
You bring food.
I think you said I will bring you food on Friday.
That's not true. Anyway, 4 weeks. And Mr. Weiler, I told him today, he's like, so we record this? And I was like, no, we sing it every hour live. Like 7 periods, we do it every period. What? I don't know if I want to do this or not.
You told me you had to.
I did, but that doesn't, we always told Mr. McClure he had to also, and, you know, you saw it that way. Mr. Allspaw is not that excited about it either. He has very small parts, Mr. Allspaw, because I'm trying to...
But it's like a soccer cast up.
Apparently.
I think Mr. Riley will do it. I just make him do it.
I might have a song for him to sing that he's supposed to say, I'm the queen, and I was like, you can change it if you want, but it's not going to rhyme. if you
Mr.
change it."
Rhodes was
I
like,
want to
when
see
you
the
do
list
this.
for literacy you can do.
He said he's going to do it. I feel Mr. Weiler is like, he's going to love it. Like, he's pretending he doesn't want to do it.
Oh my gosh,
he's
he's
going to
gonna
love
love
it.
it. Yeah. He's more of a screamo type of guy. He's not even kidding. Spill it.
I told him I have a whole bag of stuff that used to belong to Mr. Mullis, which I don't think you guys know Mr. Mullis.
Yeah,
But
so yeah.
Yeah, we all had a class.
I have a bag of stuff that he wore for lip sync.
He
Like,
was my first football coach.
He just let us watch numbers every
Yeah.
Friday because he got a headache.
And then we would complain if we didn't get to watch.
I find this bag in my closet a lot, and I'm always like, what is this? What is this?
Oh,
And
wow.
then I remember that Mr. Mullis gave me all this stuff when he left to, I don't even know. What is this?
Yes.
I'm pretty sure there might be like pantyhose.
I found where you say.
Pantyhose that Mr. Mullis wore.
And he always said it when he got bored and like wouldn't listen to it, he was like, teacher, this figure people.
You signed it, so.
That's pretty good for my figure.
Is it really?
You're probably the thing right now. Slide of paper and like this paper. While he was doing his homework, he said we accidentally broke it in half.
Yeah, I
So,
remember that.
he just put it in the trail.
Is it really that close to your signature?
It's not bad. My signature is really messy, so here we go. Let's all practice forging my signature.
Yeah, he doesn't like.
That's pretty much what I did.
I know, that's what I said. That's why I looked at it pretty closely, like, what is that? I don't think I signed that.
It looks like
That's really what your signature looks like?
Band-Aid.
Most of the time, yeah. I have to sign Parker's papers a lot, and I always think the teacher's going to think that he signed it, because I
Wait, how do you make your wires?
One time in the office for a TA, I got an email that said, did you approve someone to be your TA? Because I couldn't read your signature. Yep, that was me. Okay. So, if you see this, again, this is just saying that the x's and the y's switch. Like, this is the original function, this is the arc sine. The domain is now -1 to 1. The range is negative pi halves to pi halves. That's what we're going to have to memorize at some point. I feel like we missed a graph here somewhere.
I don't think we did.
Well, it's not on there, so.
It would have been not there
Oh,
also.
I can kick you back there.
Yeah, alright, whatever. Maybe it's next. We'll see. Maybe the graph's on the next page. Or maybe I just deleted the graph.
Let's go for the latter.
You should delete the whole flower one.
So, here's what you have to think, okay? You have to think about this is now the domain. This is the value, and you have to get the angle. So it's really easy. You can rewrite this if you want. This is like saying the sine of what equals 0. So you could say 0. We could say pi. We could say 2 pi. All of those are true, right? But you have to only give me answers in this restricted range. So 0 is the only answer between negative pi halves and pi halves that has a sine of 0. So you have to remember that your answer is angle, which in this case is 0.
What would you say?
You just say 0. The arc sine of 0 equals 0. Let's do one that's not 0. Like this one. Again, these would be on no calculator part of your test, because obviously you could type this in your calculator. That's why I put it on no calculator part of the test. Because this is saying where does sine of what angle equals negative square root of 2 over 2. But sine is what? Sine is y. Be really careful because you can only give me answers between negative pi halves and pi halves. Think about our graph, if we graph sine, negative pi halves to pi halves. Like it crosses through 0, right? So normally sine, what? We said it goes up like this and it goes down like this, right? That's what sine looks like from there. If you want to think about the unit circle, right, it looks the same, but now it's a circle. This would be pi halves. If we went backwards, this would be negative pi halves. You follow me on that? So it's kind of like definitely in quadrant 4, sine equals negative square root of 2 over 2. But can you tell me 7 pi fourths? Is 7 pi fourths in between negative pi halves and pi halves? No. So what would the angle be in quadrant 4 that would be the negative?
Wait, are you looking for like a pi fourth or like a number?
Angle. I don't want degrees, honey.
Oh, it just says it's going to be an angle. Oh, you want it right?
I want in radians. 5 pi fourths would be over here, right? Which is also negative, but that's not in between negative pi halves and pi halves.
Oh, we're going that way. I don't know what side it's in.
Here or in between here? So people say 7 pi fourths, and then you get it wrong if you write that. But isn't this the same if you just subtract 2 pi from that, negative pi fourths?
You could have said like 5 minutes ago. It's like it's all like brain words.
So here's what I want you to be aware of. You have to know this. You have to know that I'm stuck between negative pi halves and pi halves, which means I can't give anything bigger than pi halves as an answer. I can't give anything smaller than negative pi halves. Kind of, it's just nice to know. For every angle that would be in quadrant 4, you just do the negative of it, right? So you'd have like negative pi 6, negative pi fourths, negative pi thirds, negative pi halves, going backwards there. Lots of people miss this on the test because you give me 7 pi fourths. And 5 pi fourths is also not an answer because it's not in that restricted range. Grady's shaking his head no on this one. What is this saying? This is saying what angle has a sine of 2.5? What's my restricted domain up there? Oh, that's my restricted range. Can sine ever be 2.5? Yeah, there's no solution to that. I'm going to do this. Undefined. No answer, however you want to say that. If you type that on your calculator, it'll say domain error. You got to be in radian mode. Maybe. Yeah, not really. It could be in degree mode and it will still tell you that. Which means on a test, am I going to give you a question like number 3 with your calculator or without your calculator? Without your calculator, because I don't want your calculator to tell you the answer. I want you to look at that and say, there can't be an answer there. It has to be undefined. You're confused on what?
Nothing said I'm getting used to it. So I was gonna
Oh, look, here's my graph. It's just the other way. Let's graph this really quick. Remember that for inverse trig, the x's are my values now. My domain is from -1 to 1, and the y's are my angles, which is negative pi halves to pi halves. So we could say this can only go from -1 to 1. That's now my x values. And my y values are my angles, and we already know that we're restricted between negative pi halves and pi halves. So maybe let's just cut that in half there. So kind of weird. If we pick x's first, we have to pick the values that we get out of it, right? So like if you pick -1 for x, that would be saying arc sine of -1, or what angle has a sine of -1? 3 pi halves, right?
Yeah.
But 3 pi halves is not from negative pi halves to pi halves. So instead of saying 3 pi halves, what are we going to say? Negative pi halves. So when x is -1, the y value is negative pi halves. And if I pick my biggest x value I can have, which is 1, that's saying arc sine of 1. What angle has a sine of 1? Pi halves. So that gives me here.
That's it, right?
What else could we pick? We could pick 0. We already did that one. What was the arc sine of 0? 0. It's just a straight line, right?
Yes.
No. What else do you want to pick? What are some other nice sine values we can get? Oh, do we ever get 1/2 for sine?
I don't remember.
Then that's a bad thing. Here on my unit circle, is that right? Square root of 3 over 2 1/2.
Oh, see, I'm just thinking all pi over pi.
So would that be pi 6?
Yeah.
And is there another angle down here that has a sine of 1/2? Am I going to say 11 pi 6?
No.
I'm going to say negative pi 6. Oh, where would pi 6 be on my graph here?
Shorter than pi thirds.
So what's this mark I made right here? Pi 4ths. So pi 6 would be down here somewhere.
Probably be above the halfway point though, I think.
Pi 6 would be?
Yeah, because half
No,
down.
this is pi 6, this is pi 4ths, this is pi 3rds, this is pi halves. So I
No,
think,
no, the half, I mean like,
oh, you're saying like pi 6 is closer to pi 4ths
Yeah.
further away. Because pi 6 is 30 degrees and 45, so they're really only like 15 degrees
yeah,
apart,
that's what I was
right?
saying,
So you're
halfway
saying
point,
like
if it's
right there.
Yeah, that. Not
Okay. I thought you meant above there.
like,
I was a little concerned for a second. We're going to say roughly right there. So at a half, what did I do here?
Nice.
Oh, look, is this right? Is this a half here?
No,
that's
half right
negative
there.
a half. Kids, why don't you tell me the right things?
You teach us the right thing.
Because you're supposed to check the things.
Learning new things. How do we know what's wrong or right?
No, this is not a new thing. We've been doing this since January.
But I put that on my graph.
But there we go. It's just flipping the x and y's. You're never going to have to graph this on a test because it's always this. It doesn't change, right? I should put it on there, but there's no reflections. There's no stretches. There's no amplitude. This is just what it looks like. It's flipped. So for the other ones that we're going to go through today, I'm just going to show you the picture of it, and you can sketch it if you want instead of picking all the points. But I just wanted you to see that the x's and the y's switch We've graphed inverses in chapter 2. This is just now trig inverses. So let's talk about cosine. Cosine also fails the horizontal line test, so we have to restrict the domain for where does it cover all the values, where is it strictly increasing or decreasing, where does it pass the horizontal line test. So for cosine, oh, why is this like moved off to the side? There we go. For cosine of x, cosine is decreasing in 1 to 1 on this interval. So you need to say that inverse cosine, like maybe you can just write the bottom stuff here. And this up here. Oh, that's not good. Doesn't this ever work for me? Whoa. What's that just disappeared?
Something wrong.
There's something wrong with my computer.
Mouse is having his.
Delete. Oh, that looks crazy. You need to write this part, all right? For inverse cosine, we can write it as arc cosine or the cosine with the -1. It is restricted from 0 to pi. So arc sine, you can only give me answers between -pi halves and pi halves. For arc cosine, where it covers all those values and it's strictly increasing, is from 0 to pi.
Are we thinking of all 6 transactions?
No, we're just doing sine, cosine, tangent.
Is there any way to make it go up or is it broken?
No, there's just no need that you have to write all that down. Like I was just saying, this is the important part to write down. That's the graph of it. If you care to know what the graph of inverse cosine looks like, switching the x's and y's.
Looks like it's just
Arc cosine. And then we're going to do tangent, and then we're going to summarize it, then we're going to practice.
that looks right.
And you're going to practice on the homework too.
The good part is we have 3 days to do it.
You do have 3 days to do it.
Or
So that way, when you do it Monday night, you'll have no free time.
It really could go either way. Like, you have 3 days to do it, you have 3 days to come back.
Can I go? Are we still ready? Anybody's ready.
She will go.
For tangent, I don't know why that says tangent twice. For tangent, it has the same restricted values as arc sine, which is kind of nice, from -pi halves to pi halves. And think about for tangent, that's one set of asymptotes. Because after you have one set of asymptotes on tangent, it repeats itself again. So you take those first 2 asymptotes from -pi halves to pi halves, and you flip it over the x and y axis. And notice, that's exactly what tangent looks like if we would flip it over the x, y axis. And so for inverse tangent, I'm just going to write this up here. So inverse tangent, we can say is y equals arc tan x, or y equals inverse tangent. Like, don't say tan -1x, right? That's what non-math people say. When you see this, you say inverse tangent x. Yes, that's not okay to say. No. So, what you have to know is what answers you can give me. Because what I'm going to give you on the homework, on the test, is I'm going to make you just evaluate a bunch of these without a calculator. So you have to know your restricted domain and range and how to give them to me. And so on the next slide here, we'll just kind of summarize for the 3. And they don't ever give you the other ones like inverse cosecant and inverse secant and all those. They don't give you those. But the restricted values would be the same as its counterparts. But that's right. We just do sine, cosine, and tangent. And then on Monday, we'll kind of take this idea and apply it to some fun triangle problems. I said fun triangle problems. so here we go. Before we do this, we're going to summarize our domain and ranges for these, okay? So we're going to say domain for each of these, and then the range. And remember, the domain and the ranges are switched. So our domains are now like the old range values. So for sine and cosine, remember that the biggest output that you ever got when you graphed sine and cosine was 1, and the smallest one was -1. So the domains now are -1 to 1 on both of these. But what about tangent? What was the range of tangent? Do you remember? Or like what was tangent restricted between on the y-axis? What does tangent look like again? Regular tangent? Like that, right? And then just repeat itself. So what's the range of that? It was all real numbers. Tangent didn't have an amplitude because it kept going in both directions. So if we switch that, that means inverse tangent also could be any number. The range parts, the answers that you can give me, this is the part that you must memorize before we have a test. And I always remember that sine and tangent go together. They both are restricted between negative pi halves and pi halves. You really just have to practice so that you give me those negative angles instead of the positive angles. So like instead of giving me 7 pi fourths, you're going to give me negative pi fourths and negative pi sixths, negative pi thirds, negative pi halves. Those are really the values that you can give me without a calculator. And cosine is the one that's different, and it's from 0 to pi. This is the part that you have to know when it comes to the no calculator part of the test that we have in the next week, beginning of the next week. And your homework is really like not a lot of work to show. It's just practicing doing this and getting the answers. You will only have one answer for each of these. You will never have two answers like what we've been doing when we say find all the answers between 0 and 2 pi. Because if there were two answers, it's not a function anymore. It fails the vertical line test. So that's why we have to restrict it. So let's just practice a couple more of those. And again, notice that you got to know your unit circle values, your special angles. You have to know those to do these without a calculator. So when we have this part of the test again, the no calculator part, if you don't know that sine is y and cosine is x, if you don't know the values there, it really is not going to be a good part of the test. If it helps, I think I wrote this out here. Like these are the questions that you ask yourself. You should be saying, what answer can I give, right? What is my interval? And for tangent, your answer is stuck between negative pi halves and pi halves. So don't give me an answer outside of that. And then the other question you should be asking yourself is, what does this mean, right? And remember, it's saying, what angle or where does tangent equal square root of 3 on this interval? You're trying to find the angle here, right? Like what theta value has a tangent of the square root of 3? Tangent is what ratio again? Y over x. So we're looking for where the y is square root of 3 and the cosine is 1. Because remember the 2's, you can kind of like, they're just always going to cancel out. So if I'm stuck between negative pi halves and pi halves, it's going to have to be up here, right? Pi 6? Pi thirds. That's the question.
Now it goes to the y-axis.
Tangent is y over x. If we do pi 6, is y over x give me the square root of 3? No, it gives me 1 over the square root of 3. So it has to be pi thirds square root of 3 over 1. Radians. So that's it, pi thirds. On your homework, like that's what you write. You don't have to write anything else. You're welcome to write out, draw a picture or whatever, but the answer is just what angle has that value.
Who came up with all this stuff? Who came
up with all this stuff?
Yeah, it's pretty smart to figure all this stuff out. Was it Euclid? Was it Descartes?
Descartes. Descartes. No, you don't say either one. Descartes. Don't put Descartes before the horse. That's a funny joke. It is on that thing out there. It's why I bought that poster because it made me laugh so much.
I don't get a lot of them.
Yeah, that's because you're not a math person.
Wow. All three of us had this.
What about this problem?
You're not.
Don't put Descartes before the horse.
It just says calculus.
If cells can multiply, divide, and differentiate, why can't I? That's funny.
Calculus has its limits.
That's funny too, because we do limits in calculus.
Oh. You guys see
I like that
on
solid
numbers?
Some of these aren't that. Some of these are silly. Formal proof, a black tie affair. Get it? Because it's formal. Decimals have their
Square negative
points.
1 stirs the imagination.
Yeah.
What is one about complicated whatever it make complex numbers right at the top of the math system?
I don't know. Oedipus invent complex numbers.
There's a lot for the
Statistics means never having to say you're certain.
Life without mathematics is pointless. Get it? Because you do points.
Euclid died of corollary thromboplasm.
and there's another 4-letter word.
Yes. I don't know the 4-letter word.
Math is a 4-letter word. Get it?
No, math isn't just another 4-letter word.
Is it? Just a What's the restriction for cosine? Where do I have to give my answers? 0 to pi. So that's like quadrant 1, quadrant 2, positive angles only. And this is saying, where does cosine equal negative 1/2? You don't ever have to write that down, but if it helps you, write it down. You're trying to find what angle has a cosine of negative 1/2 between 0 and pi. There's only one place. So it can't be quadrant 1, right? Cosine is positive in quadrant 1. So it has to be in quadrant 2. So then you just have to know if 1/2, it's either going to be up there or it's either going to be down there. You got a 50-50 shot. Hopefully you're not just guessing. But, yeah, this one is negative 1/2 square root of 3 over 2. So cosine is x, so 2 pi thirds. And you're always going to give your answers in radians, because if you're restricted between 0 and pi, that's telling you you're in radians. It doesn't say 0 and 180 degrees. No, because radians are what we use. Radians are real numbers.
I wish they would teach us stuff at the 8th grade.
Yeah, that would go well.
Back and learning elementary is like, wow, that all makes sense now. I wish they would have never held back.
You know what I've decided I'm a big proponent of, not that anyone listens to me. I think they should teach you negative numbers before they teach you fractions. Because people really struggle with negative numbers, but I feel like it's a concept you could understand. Like, Parker knows negative numbers.
Have you noticed that you say all the time, I know you guys all are scared of fractions, I know you guys all hate fractions.
Because you do. Like, people see fractions and you freak out about it. Because I don't know why, but I think it's because you learn them too young and you don't understand the rules. So then you just never want to do them. But if you just learned your negative numbers first, and then later on, instead of whatever grade they teach you negative numbers in, that's when they teach you fractions, so you could actually understand it better and not think it's such a terrible
I
concept.
think you found your true calling.
No, that would kill someone. What's answer number 7?
I can see you like flipping out. Yeah, there you go. You did say something. 1 plus 1
It did say that.
3. No! He's not!
What's the answer to this? It's cosine, right? Cosine is x. You're thinking tangent. If I said tangent, you would be right. This is saying, that's all I wrote tangent there. This is saying what angle has a cosine of 1? That's sine. Maybe this lesson is a good reminder that we need to practice our unit circle and values. And remember that cosine is x. Cosine is 1, 0. 0 is the answer.
So the answer is 0?
At 0 radians, the cosine is 1. I think that's it. Let's see. Oh, man, there's calculator stuff. We've already been doing this, right?
Slices of paper.
Still buttons. Now you're gonna always be in radian mode if they ask you to do this. There's nothing after it, you do radians. But remember how sometimes you do this on your calculator and it gave you a negative answer, and sometimes it gave you a positive answer, or sometimes you had to add 2 pi because it gave you the negative answer? The reason why is your calculator gives you the answer based on the restrictions. So when you do, well, let's just do our cosine first. Our cosine is between 0 and pi, which means your calculator will always give you the answer between 0 and pi. That makes that true. In radian mode, I'm just going to hit inverse cosine, negative 0.7, and it tells me the answer is 2.4362.
I got 3462.
I just switched my numbers around. Are you in
ready, bud?
degrees or radians?
What's
Did you hit inverse cosine or cosine?
Oh, I just put the negative.
What's GRD? Is that short for gradient? Is there a gradient on the
I think that's for you.
Let's try it.
But look what happens when you do inverse sine. If you do inverse sine, remember. Oh, dang it. Can we change this? Make this a negative for me, please. Negative 0.31.
I did the gradient mode and it has nothing close to that.
Don't do that gradient mode. Grady is wrong. If you do a negative angle for sine, think about that your answer has to be between negative pi halves and pi halves, and the reason that your calculator gives you a negative answer is because it's giving you the answer in the right interval. Does that make sense?
I didn't get a negative answer for most of this.
I got like negative 0.3152.
1930250.
So if you do negative here, you get the negative answer, which is why your calculator gives you negative answers for negative inverse sine and inverse tangent, because it's giving you the answer in the interval. So your calculator does kind of know what it's doing something. On the calculator portion of your test, you will have to do this. So again, it's practice doing that. So some of your homework is just typing in your calculator, which is very nice. This is 4-7 day 1. You are doing 1 through 20 all 59 and 60.
Any test you can add it?
1 through 12 you should be doing without a calculator, and then 13 through 20 are just typing in your calculator. Oh my gosh, what an easy assignment.
Wow, there's like 37,000 problems.
Or 22.
Actually, I think it's only 30. Wait, no, it is 23. Wow.
Really important stuff, though, of knowing your trig values and knowing the restricted values. Two